Good morning, my YouTube viewers. Crystal here. I decided I was going to make a video this morning because yesterday I was working on the MNIST dataset. Let me just look and see if I can find out some information about the MNIST dataset very quickly for you. Basically, it's a video data set. Let me just, I know you can't see this, but I'm just going to say, what is MNIST data set? What is MNIST data set? We'll look that up really quickly. MNIST data set is one of the most common data sets used for image classification and accessible from many different sources. In fact, even TensorFlow and Keras allow us to import and download the MNIST dataset directly from their API. So that's what it is. It's a very popular dataset. So it says it's the MNIST database, Modified National Institute of Standards and Technology database, is a large database of handwritten digits that is commonly used for training various image processing systems. The database is also widely used for training and testing in the field of machine learning. So that's what the MNIST dataset is. It's to do with image classifications. And that's what we're going to be working on this morning. And we're going to be working on it with Google Colab and sklearn. So we're going to go ahead and go to the Google Colab. I've got my Google Colab up for you to see. And I don't know if you're familiar with Google Colab, but Google Colab is a great Jupyter notebook. It's an online Jupyter notebook. It has many libraries already installed on it. And so you don't have to install libraries. The libraries are up to date. All you have to do is import them. But if you if you're in Google Colab and you click onto this little directory, this little files here, you'll come up to something that says sample data. And in the sample data, it says MNIST test CSV and MNIST train small CSV. So basically, what's happening is you're not getting the entire MNIST data set. You're just getting a portion of it. Maybe you're going to get half of it. So you get, from MNIST test, you get, I think, 10,000 rows. And then from MNIST train, you get, I think, 20,000 rows to give you 30,000 rows in total to work with. And so if you're in Google Colab, if you want to go into the MNIST dataset, you can see that. So we're finished with that. And how you access the MNIST dataset from Google Colab is you go to where it is, and then you just say, click here where it says copy path. So you copy path of the MNIST test, and you copy path of the MNIST train small. So on Google Colab, the train set data set isn't the full data set. You just get a part of the train data set, but it's still enough to work with, which is what it's all about, working with it. So now we're in Google Colab. If you've never used Google Colab, this is a good time to actually go into Google Colab and use it, because you can follow along with me. So the first thing that we're going to do now that we're in Google Colab is, if I can find out, is we're going to import the libraries. So the two libraries that you want to import are Pandas SPD and NumPy SNP, because those are going to be the two main libraries that you're going to be using. We're going to be using other libraries, but we will import those libraries as we need them. And then what we're going to do is we're going to import our CSV file. Train equals pd.read_CSV, and that's the path of the train small CSV. And these files do not have headers, so you need to put header equals none, because if you don't put header equals none, then one of the rows will be the header, so you don't want that. And then you do test equals pd.read_CSV, and then the path of test CSV, and you have to put header equals none because the files don't come with headers. So you can see the train file here. So column number 0 is the actual number, and then column 1 to 784, I believe, is binary logic. It's going to be either zeros or ones. So it's it's going to be 784, I believe, columns by to make a number. So let me just get my phone out, because my phone has a calculator on it. So let me just get my calculator out. And so we're going to say 785 divided by 3 equals, no, that's not right. So we clear that. So 784 divided by 3 equals, clear that, 255 times 3 equals. So 255 times 3 equals 765. So that's a bit unusual because it says 765. So let's try it again. 256 times 3 equals 768. Well, we'll sort this out later because this says 2,000 rows by 785 columns. So that's what it says. And then we go to the test file. And the test file is 10,000 columns by 785. And that includes your 0 column. So your 0 column is the actual number on the train file and the test file. So what I decided I wanted to do was, on the train file and the test file, you've got your target. So your target is column 0. And so I decided that what I wanted to do is I wanted to append the test file to the train file to make one large file. So we did train equals train.append test.reset index, and then train. So now you can look at it. And so this says 30,000 rows by 786 columns. So that's something that's really unusual. So what we're going to do is we're going to run this all over again. So it'll give you a chance to see it running, because there's definitely something wrong with this. So that says we ran it all over it again, and it says 785, 785, and then this says 786. And what happened was we reset the index, and because we reset the index, that gave us an extra index column that we didn't have before. But we're not going to be worrying about the index anyway. But so what I'm going to do is I'm going to say here 784 divided by 3 equals, no, that's not working. And then so we've appended it. So now we've got 0 to 29,999. So that's 30,000 rows. And then we have reset our index. But we're not going to do anything about the index at the moment. So what we want to do now is we want to check for any null values. So train.isNull.sum.sum, and it says there's 0 null values. So that's good. So you don't have any values to impute. And then if you did have any values to impute, it's unlikely that this data set would work anyway. So now what we want to do is we want to define our X and Y values. So I would like to say that all of the columns are numeric, so you don't have to worry about that. But what we can do, all of the columns are numeric. The first row number 0 is the numbers, that's your target column. And then the rest of the columns are Boolean. But what we can do here, since we're in the program anyway, we'll come over here and we'll do a train.info, check on info. And so it says 30,000 entries, 0 to 29,999, 786 entries, index to 784, and it's all integers. So that's good. So now you've got some more information about this file that you didn't already know. So now what we want to do is we want to define our X and Y values. So your Y value is column number 1, because you remember in Python the first column is 0. So because we have appended test to train and we reset our index, we actually have an extra column. So what you want is you just want to take out the Y column for your target. So Y equals train.ilog : 1. And then on your X file, your X variable, you want to use all of the rows, and then you want to start with the second column, because remember Python starts with 0, and then all of the columns from the second column. So that's what we did there. So here you have your X. So now you've got your X, which is your trained data set, where it doesn't have the index and it doesn't have column 1. So it's got 784 columns. And then what we're going to do, so it's got 784 columns. So we have to reset our data. And in this data set, these images, in this data set has images with pixel values in the range of 0 to 255. And so we have to scale our data. So X equals X divided by 255. So let me just say clear here, 255 times 3 equals 765. So I'm not sure exactly why it does that, because 255 times 3 is 765. But you want to divide the data set by 255. So we'll do clear, and 784 divided by 255 equals 3.07. But that is how you standardize, scale the data. And then I think I asked the question, why scale MNIST data by 255? And so it gives you the information. If you look at, someone said, a lot of people ask the question, why we have to scale by 1 to 255. And it says, and there's lots of questions. If you do a Google search, there's lots of questions on that. But the pixel values, the MNIST data set has images with pixel values in the range of 0 to 255. So that's 256 really. So we'll just say 256. So let's say go back to our calculator. I know you can't see it. 786 divided by 256 equals 3.07, so that's not working. 784 divided by 256 equals 3.0625. So it doesn't really it's not a clear 3, is it? But that's what the pixels are. The pixels range from 0 to 255. And so that's why it's saying that you have to do that. You have to scale it by dividing x by 255. And that's just the number that they say that you have to do it by. And I'll probably, when I make my blog post, I'll research this and find out why you have to divide it by 255. But just know that in order to scale the MNIST data, you have to scale it by 255 because the pixels range from Boolean data, zeros and ones, from 0 to 255. And when I do my blog post, I'll investigate that some more. So if you want to know more information, you'll have to look on the blog post. So now what we do is we split our training set for training and validation, and we're going to use sklearn's train test split to do that. X train, X val, Y train, Y val equals train test split. XY train test size equals 0.1. Random state equals 1. And then we check the shapes. So X train is 27,000 by 784. X val is 3,000 by 784. Y train is 27,000 and Y val is 3,000. So now what we do after we split our training setup, X setup, what we're going to do is we're going to define our model. And in this particular case, we're going to use our MLPC classifier. And your MLPC classifier is sklearn's neural network. I think I may have it up here. If you just, I know you can't see this, but if you look under sklearn, if you do a search on Google, sklearn MLPC classifier, MLPC is multi-layer perceptron classifier. And what this is this is multi-neural network of sklearn. sklearn has its own multi-neural network. So you may have heard about Keras, or you may have heard about PyTorch, but you don't have to use those libraries. You can just use sklearn. I find sklearn quite easy to work with. Keras is more difficult to work with. I've tried to use Keras on other data sets, and I'm just not very good at it. And so if you can get the grips of sklearn, which is a lot easier to use than TensorFlow or PyTorch, which I've never really used, then you're going to fare very well. So model equals MLP classifier, hidden layers equals 50, max iter equals 10, alpha equals 1e to 4, solver equals SGD, verbose equals 10, random state equals 1, learning rate equals 0.1, and you fit X train, Y train, and then you get your iterations, and you can print off your accuracy, and your accuracy is 98.94%. And if you actually do go into sklearn, they'll tell you what everything means. They'll tell you what your parameters means. So you can like tune your parameters to try to get the most accuracy out of this. Try to get the most accuracy, and you know, it takes trial and error to do it. Everything does, but I like MLP classifier, but it doesn't always work. Sometimes you have to use HIST. It depends on what you're working with. Sometimes you have to do HIST gradient boosting classifier for some of the files. But this particular file, it's MLPC, it's a neural network, it's sklearn's neural network. So we've said enough about that. And whenever I do my blog post, I'll go into that. So now what we want to do is we want to predict on our validation set. So that's what we want to do. We want to predict on our validation set. So what I'll do is I'll come over here and I'll say so we predict on our validation set. And when we did that, we had an accuracy of 96%, which is good. And so now it just says print. So you can print your training set score is 98.9% and your test set score is 96%. But we can change this and say validation set. So then that'll just say validation set. And then what we've done is we have created a data frame. So we created this data frame so you can compare the actual values against the predicted values. So if you go down just this one little data set here, you can see that there are some mistakes. Like in row number 3, it says that you had the actual value was 5 and the predicted value was 8. So this MLPC didn't get 100% accuracy. But you can look at the actual values and compare them against predicted values if you want to. And then now I've got some code in here for the graphics. So this is the graphics code, and it's supposed to give you a picture of what the numbers will look like, but the picture doesn't look very well. And it says something in here, reshape 28 by 28. So 28 by 28 is 28 times 28 equals 784. So that's where you get the 784. The pixels are 28 by 28. So that's where you get your 784, 28 times 28. So that concludes this video on getting to grips with the MNIST dataset using Google Colab and sklearn. So I'll go ahead and run this again. So I did the program beforehand, and so we're just doing a code review. But you can see that I did do a few little changes on the code during the video. So you can see that, yeah, I can do a little bit of programming. Sometimes I have to get code from other places because I'm still learning. I've only been working on data science for about 6 months now, so I have to get code from other places. So I suppose this concludes our presentation on the MNIST dataset. And if you like my video, please like, subscribe, and share. If you want to keep receiving my videos, then please press the little bell button to the side when you subscribe. And the reason why is because if you don't watch my videos, then what will happen is after a while, YouTube will just unsubscribe you. And if you like the work I do and want to make a donation, I've got my email address to my PayPal account in the description box down below. And the reason for that is because I don't have enough viewers to monetize, and because I don't have enough viewers to monetize, I have to actually ask for donations, which is what I do. So I will be making a blog post on this, and then when I do, I'll have to save the file to GitHub, and when I save the file to GitHub, I will give you the GitHub web address. So if you would like to have the code, then you will need to read the blog post, and then that will give you the link to the code. So thank you so much for watching this video, and I look forward to making more videos for you in the future.